Hi everyone, Ryan Duffy back again from Precision Microbes.
And Tommy Heffernan here, Precision Microbes. Tech in 10, our weekly kind of look at a technical topic in under 10 minutes.
Yep.
And this week, we're going back to basics.
Going back to basics, very, very top level here, talking about the whole immune system.
Immune system. We're going to do two parts. So this week, Matthias is mad to press go, so we better get started. But 1 second, Matthias. We want to emphasize this is two parts because we talk about the gut and immunity. So we said, let's go back to basics on the immune system again. Do a discussion on it, and then part 2 next week is the immunity and gut, because that's so important. It's really an exciting space in animal health and even in human health.
Yep.
Right, let's go. 10 minutes. Immunity. Ryan, what's your version of what is immunity?
Well,
immune function, we'll say.
Yeah, but it's the part of the body which fights off infection. That's how I would define it, very, very straight and plainly speaking. Now, obviously, it's quite a complex side of things, but it's ultimately the part of the body which fights off any sort of invading forces, be that bacteria, viruses, fungi, protozoans.
But I'm right in saying inflammation as well. If you get a bang of a hammer on the finger, it's an inflammatory and infectious response, isn't it?
Well, it's non-specific. We're going to get into the non-specific elements here where if something is disrupted at all, the immune system will react, be that a cut, be that slap from a hammer.
Yeah, okay. We're not slapping anyone with hammers here in Precision Microbes. Okay, so immune system is key to the whole health story. So why is it important? I always go back to my seesaw. I don't know if you can see this in the camera, that no matter what infectious disease you're dealing with, on one side you've immunity and on one side you've infection pressure via pathogen load. You're always trying to drive up immune function or immune capacity and drive down the amount of pathogens animals are exposed to. When you see disease outbreaks, something has tipped this pretty much. So when we think about infectious disease, which as vets we spend a lot of time talking about, immune function is key. Now there's a load of factors that affect the immune system. Maybe that's a separate video again. But that's to me is a basic side of it, isn't it?
Yeah, no, completely. The one thing I will say is we're very much as vets focused on infectious diseases. There's obviously a variety of other diseases, be that nutritionally based or whatever. And ultimately, if you're keeping the immune system right, you can keep even non-infectious diseases away as well. So it's not just infectious disease. I know we focus on it a lot because...
A good example of that is calf nutrition. Like white blood cells, which are an important part of the immune system, they require a lot of energy and glucose. So if you have an animal that's nutritionally under pressure, metabolically under pressure, we see that animals are going to have weakened immunity.
Yeah.
Okay, we could get caught up. So we're going to talk about, so we know it's important. Look, it's basic, but there's two elements that are important to understand in the immune system, aren't they? We have, and I went to a talk on the immune system 2 weeks ago, and I said, God, this is good to remind yourself of these things. Innate and acquired. So innate's kind of the basic, non-specific immune function. Talk about the different levels.
Well, it's something that we inherently have.
Okay.
So, even I'm looking here at yourself, and you could do a wee bit of trimming in the ears and the nose, like those nasal hairs. Those nasal hairs and everything. That's something you inherently have. That is something that is there regardless of circumstance. So that's an example of
your
physical barrier.
So your skin and your mucous membranes are a physical barrier.
Definitely.
Okay. Then we talk about the innate chemical barriers. This again is something you're born with. Stomach acid is one of those things that people often don't think it's innate immunity. It's 1 point, whatever it is, very low pH is a defense mechanism.
Yep.
Any other examples?
Well, you have things like cytokines and that thing that starts that inflammatory process that you're talking about. They're like chemical weapons, essentially. They would also be included in that category.
Hammers and chemical weapons. We're at it today. Cellular then. So these are the white blood cells, essentially, that are in our lymph system, spleens, other organs. What's cellular? The basic cellular innate immunity that everyone has.
Yeah, so it's very easy to get consumed by antibodies and stuff, which we will get into. But these cells here are the ones that pretty much attack anything that shouldn't be there. They don't really care what it is. They'll just go after it by a process known as phagocytosis. So that'd be your neutrophils and your macrophages.
Okay.
So again, you can see in what you're saying, or in line with what you're mentioning, non-specific. They're just going, if they recognize something that shouldn't be there, they will just consume it.
And then we talk about kind of inflammatory reactions. Is that the same thing, inflammation?
Yeah, they're very much kind of all intertwined. As much as we'd like to put them all into different categories, they are intertwined.
Okay, so that's your innate basic immune system.
Yes, everything you're born with.
Okay, and then we talk about acquired immunity, okay, which is the next step up. It's the memory part of it.
Yeah.
It's the adaptation of the immune system to, as we age or animals get older. Where does colostrum fit in here? Where does colostrum fit in foals or calves?
Yeah, ultimately it is nearly like an acquired immunity, because we are essentially donning an immunity upon an animal, or its mother is donning an immunity. But we often refer to it as passive transfer,
Okay.
because it's something that should naturally just occur. Whereas acquired immunity, you don't necessarily acquire immunity to every single bug. You only acquire them to the ones that you're exposed to.
Okay.
Whereas this is more of a passive process.
Okay, the red guys are the bugs here in this one. So let's talk about the acquired immune system, the way the immune system works. So we've got a salmonella here, a bug, or some sort of a virus coming into the body. How does the immune system work, the acquired immune system work?
Well, first thing is, it will recognize little components of this salmonella or crypto, whatever you want to call it, and those are known as pathogen-associated molecular patterns. They're essentially a little thing that tells the body these are foreign entities that should not be in the body.
PAMPs.
PAMPs. And we have pathogen recognition receptors on our cells. So these are a piece of Lego that essentially attaches to this and tells the immune system we have to go after these guys. They're not supposed to be here.
Recognize the invader, and then you have a response.
Definitely. Yeah, exactly.
So the response, when we think about neutrophils and we think about macrophages, this is more your leukocytes, your T cells, and your B cells.
Yeah, your more learned response, something that you've acquired over time. And it's the start of nearly a memory, so it is.
Okay.
Yep.
So response, and then that response is an inflammatory reaction. So when an organism invades the body, basically, like every day we have organisms going in. We see in animals and ourselves, we see very little response potentially, or we see the physical, clinical symptoms of this. Kind of is the response. So it's often not the pathogen; it's the response that the body's immune system gives us the physical symptoms, isn't it?
Yeah. There's another guy in here called interferon, and that's really responsible for causing a lot of the temperatures that we get and stuff like that, and the sniffles. So that would really be the sort of stuff that we get whenever we're not massively sick, but we know that something has happened.
And it's the same in animals.
Exact same in animals.
And then you get resolution. That's a recovery, or obviously not, but this is skull and bones. So if we think about the resolution and the immune system, we think about the memory then. This is an important part of acquired immunity. You're exposed to a pathogen, there's an inflammatory or immune response, and then memory is created. How does memory work in the immune system?
Yeah, so these cells, they've been exposed to something, and it's a matter of them just remembering over time. So we have the likes of B cells and T cells. These are white blood cells ultimately.
Yeah.
And these guys will produce antibodies, which will act as a longer term defense. If something similar like this invades again, we'll have antibodies specifically directed against them. Very different to the innate defense, which is kind of fast, furious. It's first to the game, but it's not specific. This here is where we have specific antibodies for a specific bug. These T cells, they're the guys that kill infected cells. So again, they will come back around as being more specific, more memory based. Again, we're talking about memory here. You don't know how to spell acquired. You can't remember how to spell acquired.
The spelling would not be a strong point, Ryan. Yeah. We should do a spell check beforehand. Right, so, okay, it's a good to have an overview because everything comes back. Okay, I go back to the seesaw. Immune function, we think about infectious or inflammatory diseases. What we see in our farm animals is more infectious acute diseases. What we see in our pets and our horses typically can actually be another side of the immune story, which is inflammation. So when we think about immune diseases, where do you fit that in? We're running out of time here, but where do you fit in inflammation or chronic inflammation? We're going to talk about the gut in our next video series.
Well, yeah, that's just a matter of the system's not being shut off. So the body has recognized something as foreign, and for whatever reason, it doesn't know when to turn off. That could be because the pathogen has not been removed from the situation, or because the actual immune system has developed some sort of adverse reaction to.
Is that what we talk about, an allergy versus an autoimmune disease?
That's exactly it.
Okay, so the immune system is sort of really key. If I was looking at the time, we've a minute left. I think the big factors I think from an animal health perspective that drive it is nutrition. Is huge for me if I was picking one. Stress, reduction of stress, because stress suppresses immune function through cortisol.
Yep.
Nutrition drives immune function. If I was thinking about overviews of things that I would see People will talk about vaccines to stimulate immune function. We're going to talk about microbes in the gut, in that piece next week. But nutrition and stress are huge factors when we think about immune function, aren't they?
It's this here is pillar, and minimizing the stress. Yeah, that's absolutely key.
Okay, hopefully we've given you an overview, very basic, but it's no harm to think about the immune system, because our next video we're going to talk about the gut and immune function, and over 70% of this system is in the gut. We'll explain how it works next week.
Yep.